Okay, so this is problem 15 of chapter 9 of Giancoli 6th edition. So they want us to calculate the force Fa and Fb on a beam. So let me make the drawing that is given to us. We have this long beam and it's touching these two points here, these two legs here, and we want to know what is this force here, this normal force Fa and this normal force Fb. Now on this beam there are many different objects, there are some machineries, and they give us the position and the weight of all of these additional objects. So here there is a weight, and this object is 2 meters from this edge. There is another one here, this distance is 4, so this whole distance here is 6 meters. There is another one at a point here, so 2 plus this 4, 6, and plus this distance here is 3, so this whole thing here is 9 meters. And then there is the force Fb. The whole length of this beam at the end is 10 meters. Okay, so this problem is not so hard. All the weights are given, but we cannot forget that there is also the weight of the beam, which is not included in this drawing. So this is an important step that we have to remember. The weight of this beam goes here in the middle of it, 5 meters from each side. So once we remember to include this, then the rest of the problem is not so hard. How can we solve this problem? Well, we should include the sum of all the forces in the y direction, but then we'll have two unknowns, the Fa and Fb. Then we can use the torque, using as x of rotation one of those points, so either on Fa or on Fb, so we don't need to worry about one of these forces, correct? So let's do that. I'm going to start writing the sum of all the forces in the y direction. And what we have here is, I'm going to assume that up is positive. So I have Fa plus Fb, and then, plus Fb, and then negative all of the other weights. And so I'm going to call here this weight 1, this weight 2, this weight 3. You have all these numbers, and do not forget to include also the weight of the table. So minus weight 1, minus weight 2, minus weight 3, and minus the weight of the table. All this is going to be 0. So then you see here the two unknowns, the Fa and Fb. So then let's move to the equation for torque. Sum of all the torques will be equal to 0. Okay, so let's sum all of these torques. For this we need to choose one point as our x of rotation. So a good point is in one of these forces. So I'm going to choose this point here, right where the force A is, so I do not need to worry about this force. Then we go write the torque for each one of those forces. So I have all of these weights, weight 1, weight 2, weight 3, the weight of the table. I'll try to rotate this table, this beam, clockwise. Fb is the only one trying to rotate it counterclockwise. Okay, so this means that it will be negative, the torque done by each one of these weights. So it's going to be minus weight 1 multiplied by that distance 2, minus weight 2 multiplied by that distance 6, minus weight 3 multiplied by that distance 9, and then do not forget to include also the weight of the table, again negative, minus mg, and that distance is 5, and then finally our unknown, trying to move clockwise, so plus Fb, and that whole distance 10. All this is equal to 0. So now from here we can find Fb. Once we have Fb, we can find Fa.